Okay, you can fire away, Jonas. You have to unmute yourself.
Okay, thank you. I guess then we can start with this Earth2Vec community call. I want to welcome you all to this community call here. Romeo asked me to do the moderation this time. So I am Jonas. I am a researcher in the University of Münster in the Institute for Geoinformatics, and I am part of the Embed2Scale project, which is how I came in touch with all this embedding magic that we're discussing here. So as always, we should start with some updates from the community. So if you have achieved some nice things or did some nice things with foundation models and embeddings, we would like to hear from you what you have done or what you have achieved since the last meeting. Just feel free to speak up. Wow, so many contributions today. So someone asked if I could repeat the prompt. I was asking about progress in your project that you may want to share with the community since our last meeting, what you have done with embeddings or what you have achieved.
Hi, happy to take a stab here. This is actually my first call. I was just recently invited to it. So haven't directly worked at embeddings, but looking to do it. Currently leading a project called Trickypedia. What we've done is we have sort of consolidated a lot of tree-related databases into one single schema, and we are doing all types of regression and correlation analysis between that schema and complementary data sets like intact forest boundaries, elevation boundaries, soil types, rainfall, etc. And now we would be very interested to start sort of intersecting that species knowledge data and occurrence data against embedments. So that's my quick update. Thank you.
Thank you very much for sharing.
Yeah, me also. I would like to share, like, I'm new in this community, so and I've been working lately with some embeddings using Spain's orthophotography, and I've been working in an application for indexing all Spain's orthophotography in order to have search with a text, search with images, and also search with areas. So yeah, that's been my work with this kind of embedding models and embedding world.
Thank you very much for sharing.
Hi everybody, I wanted to say hi. It's my first time joining this recurring meetings, and I'm from Mindert. I don't know if this is the right moment to, I was a little bit late. Jonas, can I introduce myself?
Feel free.
Yeah, thank you. And yeah, I mean, I can give a quick overview of what we're doing at Mindert with embeddings. And we also were at the ESA-NASA workshop, the ESRIN, in May. We presented a work where and also slides are available now. So if anyone is interested, I can share the link. And we presented this work where we try to predict origin destination metrics of mobility data using a graph neural network fed with aerial orthophotos embeddings. And in general, we're trying to, let's say, at production level, to to switch all of our pipelines and processes into, let's say, at least having an embedding-based step at the beginning, and then switching, I mean, feeding them to downstream classifier. So we were trying to, let's say, move all of our processes in this direction.
Thank you very much for these insights. Okay, then if no one has any more community updates, then I think Bruno can go ahead and tell us about Clay 1.5.
Yes, of course. This was, I know that the Google embeddings discussion is postponed for next month, but there was also quite a few people with questions or things that if you're okay, I would love to give a space later if someone wants to share something, because it seems to be like the moment to talk about that. And on that context, we also got a lot of mentions to the Clay model. So my connection is a little bit finicky, so if I disappear for a few seconds, I'm sorry. Can you hear me?
Yes, we can.
Yeah, sorry. Okay, so I'll try to give a general overview of what Clay is, to give everyone space, and then if you want to ask questions, please ask away anything. The whole idea is that we realized there was a space to create, 2 years ago, to create a fully open data, fully open source, fully open license model to understand satellite images, to understand Earth. So we basically took the tricks that we've seen in many other papers and combined them for the modality of Earth. After Clay came, there are many other models that came, like Terramine or the Google model or many others. And even though they are better in some benchmarks, I would say, and please correct me if I'm wrong, anyone, that Clay remains to this day the only model that is, one, open, fully open to do whatever you want with it, and two, able to use any resolution of any instrument of any number of bands and wavelengths, to the point that you can use Clay for things that is not even designed, like digital relation models, and it will still generate embeddings. But the farther you go from the training set, the less we know if it works. So the general sense, the model is not an embeddings model specifically, it's a mask autoencoder, which is basically the typical GNet when the input data goes to embeddings, and then from embeddings back to reconstruction, and you try to make the reconstruction work. It uses, as I said, a few tricks because we try to make it as useful as possible. And by the way, Daniel from Development Seed is in the call, who were the ones that actually coded. And if Clay has a mother and a father, they are definitely one of them. I don't know who's the mother and the father, but they will be keen to answer questions too, if I say something wrong. So one of the key things, again, that I think Clay makes Clay different is that you can take any instrument, and then the DOFA paper, the Do One for All architecture, will take the wavelengths and the number of bands and convert that into a common space. And after that, it doesn't really matter because everything is treated the same. So the intuition is that then the model understands semantics through wavelengths. So that's why you can use hyperspectral or other things which we've used Clay for. Then after that is the typical visual transformer with a few other tricks, like a Dino B2 teacher model to allow the model to consistently learn without collapsing into one of the modes. And we also tried things like Matryoshka, but didn't work. These are for the technical people, so I'm mentioning that. For the non-technical people, it's basically papers that came out before Clay that we thought were really useful. If we had to use to make Clay today, we would make it differently. And then you make the embeddings, and then you reconstruct. When we save embeddings, and we've been very huge proponents of embeddings, and when we say that, in our case, it means the class embedding. So these models create embeddings for each patch, but also it creates embeddings for the whole image, the class embedding. That is the one we save, and that is the one we talk about, and the ones we upload to source code, to source cooperative, the ones we also use at the company we started later, Legend. The class embeddings, I refer not the patch embeddings. They have 1,024 dimensions, float 32. It's clearly a lot of dimension, and it's clearly a lot of space, and we can talk about why would that make sense or not, and how we should divide that. Comparing, for example, to the Google model, they use, I think it was 64 dimensions, and they are casted to smaller spaces. So they are much more efficient in that sense. But they're also the pixel level. They don't have a class embedding. They save basically the patch embeddings. So that's kind of the basic architecture. And the idea is that these models, we know transformers are really good at encoding texture, and semantics through texture. It's a very powerful way in many domains to understand the data. So that's what we're hoping with that. We know that Clay is not that good with temporal semantics, because it only approaches time as frames in a video approach. But it's also pretty good. Like, we've done analysis of detecting forest fires, land cover changes. We've also done regressions, and it's generally good. It is also, and if you have questions, please put it in the chat. And if you really want me to answer one that I'm not answering, just thumbs up or something. But I don't see many questions there. One of the things I wanted to mention, besides Romeo, he's the one who will ask Doug in the code, because you help us make it pip installable. So thank you, Romeo, for helping in that repository. It is not in the standard benchmarks. The only reason is because it is also there's not a paper for Clay, and the reason is simply lack of bandwidth. We did a lot when we had a lot of funding. We got $4 million on philanthropy compute to do that, philanthropy funding to do Clay, and then we ran out of the money. So now we are much more restricted. So when we had the bandwidth, we wanted to work on the model itself, not so much on the academic assets of like a paper or benchmarks, even though they are important. One thing I would say, though, is that I am surprised, and I love to hear other people's thought, that we use linear probing, linear models to see how good the models are. But linear probing is, it is not gonna work well, because it's linear. So any non-linearity on the models, it's not, sorry, my kids coming to the room 1 second. Yes, sorry. So when we say that an embedding, imagine that it's 1,000 dimensions unit sphere, and it's encoding a lot of semantics. Using linear probing is literally making a flat plane on that hyperspace. It's a weighted sum of the dimensions, which to me seems a very blunt way to collapse all the dimensions. All the non-linearities, all the directions you can approach similarity are collapsed into one. So to me, it's not that surprising that in that tool of linear probing, you're not going to see much benefits, because in my opinion, you are not able to squeeze all the juice from models like Clay. I don't know if others agree or disagree, but that's some of the thinking of that. And this is not a presentation. I wanted to give a space also to people to ask questions, because we got a lot of questions with the Google model. So just giving space now for people to ask or disagree with me.
Here is Paolo, just a comment on from IBM Research, from that comment you made about the benchmarking, right? I fully agree with you, and at least I'm not sure if you know, if you remember, we are involved in this initiative, GeoBench 2, but also GeoBench 1 as a benchmark. basically we are trying to use the decoders that one would use in practice, right? Linear probing might be okay for classification if you wanted to do it, but then for the others, it makes no sense. And in that regard, also Pangea does the same. So it depends which benchmark you look at, but I fully agree on that one, because in the end, we just want to, when we, as you said, maybe academic papers are less important, but at least what I think is important is really to understand the performance, and the only way to do it is through you know, a number of tasks, and putting the models in the situation they would be in the real world. So, for example, in my opinion, full fine-tuning should be the way to actually squeeze out everything you want, because then you have to pick which model you're going to use, right? And if you have the GPUs, or you will not freeze your encoder a lot of the time. But obviously, if you think about embeddings, then it is important. But again, embeddings plus a UNet decoder, a UPerNet decoder, or something like that. So fully agreed on that.
No, and also worth mentioning that benchmarks, academic benchmarks, like the ones you are developing, are important. I'm not saying they're not important. It's just that we didn't have the time to do more of that. But there's also another class of benchmarks, which I think are equally important and are less paid attention, which is the practical use, in the sense that, is the model open? Can the model run in a laptop? Can the model run in a cheap thing? It's like those things that are subjective, because for some people there are some restrictions, and for some people there are other restrictions. Can I build companies on top of that? Like, for example, the Llama model might be great in benchmarks, but the license they chose makes it that anything commercial you want to build is going to be tricky with the license they chose, right? So there is the objective performance metrics and benchmarks, which is important, but it's also the subjective or per user benchmarks of, is this usable for my use case or not, which is also important.
Agreed.
I see Francesco has a comment or a question.
Yeah, sorry, my camera is really slow at starting. Yeah, I wanted to give my more industrial maybe perspective on this. And I don't know if it could be somehow reasonable to think about this for benchmarks and validation, but more from a product perspective, we found a nice duality between in the two-step approach I was mentioning before in developing our pipelines. We find a good duality between the embeddings and gradient boosting trees for let's say classification and regression. So that's how we're moving, and I think we are not the only one.
That is a really good comment. In general,
sometimes, sorry, let's think about this, is that as you I think know, the main differences are that with gradient boosting trees, you can have very from a spatial perspective, you can have more high frequency results. Could be also more noisy. So, you know, with everything that somehow is more fully connected and you work convolutional, you get low pass results. And also they work very well at squeezing the nonlinearities. So that's what we were seeing in our tests.
Yes, thank you, Francesco, for those comments. Nonlinear ways of testing embeddings to me are crucial. Like when people use linear pros or PCA, which is linear pros in orthogonal directions, I'd say it's okay, it's valid for some cases, but it's not that valid for many others. Nonlinear ways, like I love random forests and other types of trees for that reason, or even cosine similarity. Cosine similarity, I think, works very well in some domains, but for our domain, I think it has a lot of limitations. One of them is that cosine similarity, unless you do it manually, is going to take into account all of the dimensions, but the semantics might be encoded in some of the dimensions, which is something the random forest does naturally. So partial cosine similarity would be much better than normal cosine similarity, but then it's really hard to do those things. at scale, which is the other, like I wear two hats now, which is a nonprofit to make the model, and then the for-profit with Legend, which is making services on top of models. And we see those difficulties in both sides, and I'm keen to talk about and figure out together in this community how to understand embeddings, which is one of the objectives of this community.
Thank you very much. Any more questions for Bruno?
So there's a question for Jimo on how clays can be leveraged to predict above ground biomass. We did, one of the use cases we got funding for was to do that with seed trees data, and it worked really well. And it was just a layer on top of the embeddings, MLP layer, fully connected. And it worked really well rather quickly. We haven't done much more than that. And one of the struggles we have is that because clay is so open, we don't really know who uses it. So we only know when people have problems, and there's a lot of problems. The documentation is pretty outdated, and that's kind of the things that we know that people have used in many commercial companies and have used clay for exactly this and have built commercial services on this, but we only know when they tell us. So I can tell you that there is a use case for using with seed trees. I also know that other companies have done that. And the support for hyperspectral, how to do that is pretty easy. So the inputs of clay is, there's a metadata file where you say, my input is called, I don't know, Bruno satellite. And the Bruno satellite has 100 bands, and this is the wavelength of each of the bands. And this is the normalization values, the mean and the standard deviation, and that's it. And if whatever you put there is going to work. If your instrument has 1,000 bands and you have enough memory on the GPU to put all of those, you can put all of those. It's gonna do the same.
Well, if you're wondering who's using the model, I can tell you a bachelor student of mine is now doing his bachelor thesis with a clay model.
I love it. I love it.
When he's finished working, I try to get him into this community to present to you. So
yes,
there's another hand.
Please do tell us when it works, but also please do tell us when it doesn't. We don't claim that clay is the best. We want to make it better, and we want to make it useful. We spend a lot of money and emissions to make clay happen, and we put it in the open because we thought it's a way we can work together with the most value. So please do tell when you use it.
So there's a hand raise by, I'm sorry,
Please.
I do not know how to pronounce your name, but there's a hand raise.
So Jason, maybe first. Yeah, Jimo is second.
You put a question in the chat, so I'm going to answer that. If it's not that, just unmute yourself and say so. And the question is about cosine similarity comparing not all the bands. No, I don't mean the bands. I mean the dimensions. When you, Jason, yes. Oh, of course, Jason. I didn't know it was you. Please restate the question.
Yeah, I wanted you to expand a little bit more on that. And is it? I don't mean bands. Sorry, I meant dimensions. So are you saying that some of the dimensions, it sounded like you were saying some of the dimensions aren't useful, in which case, like, could you expand on that more and like why they aren't useful? And then if they aren't useful, like why are they in the embedding?
Yeah, so this is where I start. It's more a hunch. I don't know, right? And this is something we can figure out together as a community. But imagine that a model has 1,000 dimensions like clay, and it happens, and we can talk about why that happens. Imagine that the semantics of, I don't know, wheat is in one dimension, right? So, and the rest are associated with something else. Because remember that an embedding is not one semantic. An embedding is all the semantics that are co-located in the same chip, which is a huge problem for us because it's this co-located plurisemantics. It's a problem for figuring out how to use embeddings. So imagine that the wheat or not wheat, like how much wheat or rice is there in the chip is one dimension. So if you do cosine similarity is the angle between one embedding and the other, considering all of the dimensions by default. So if only one of the dimensions is the one you're interested, you're gonna get influenced by the rest of the dimensions. So it's gonna hide the reason. And now, why would semantics be encoded independently in dimensions? I don't know. It's my hunch by how models learn through the way they ran, the mask autoencoder, the linear projection of the pixel values, and all of these things make me believe that is the case, but I don't know. What do you think?
Okay.
You are one of the experts of these things, so your feedback would be hugely appreciated.
I don't know about being an expert, but it does make sense that it would be encoded. I'm not sure. It feels like, part of the discovery of the embeddings is testing things like this. And I would imagine that it wouldn't be just one embedding, like wheat's this dimension and oats are in this dimension, but that it's probably more like multiple dimensions and different percentages of them.
Yeah. But the point, even if it's just a subset of them, the point of getting noise of the other semantics is huge.
Yeah. I was wondering about this because, inadvertently as a user, you select an area, you want to find similar areas. It doesn't know what you care about within that area. It's going to choose everything, which might be moisture level, and you may not care about that or something else that's captured there.
Yeah, it's like having a dictionary that defines in groups of words.
Okay, thank you.
So I see Jimo has a raised hand.
Yes, sorry for coming back up again. This is super interesting. I'm actually not a machine learning expert, more on the ecology field, but I would imagine one of the big constraints is sort of just groups working on big enough data sets that perhaps were not used for the training of your initial models, but that now might leverage Clay, for instance, to solve complex problems. So one of the ones that I'm particularly very interested in is sort of species detection, sort of RGB or hyperspectral. And there's a lot that we've done that could help support these predictions. So for example, occurrence data within certain intact forest types and how they're distributed across the world, I think could help on the predictions. But I was just curious, because you did mention collaborating with C-trees on some stuff. Curious if any of that is open source, any of the trained work is available, or if you at least know perhaps groups that might be collaborating across the world on some of these forest canopy topics. I would absolutely love to join some of these efforts or get connected to them. Thank you.
Okay, so on the species detection, it works so well. It's almost uncanny how well it works for some cases. When a species detection depends on time, like crop, like the similar fields of plants that look similar, but through time you could distinguish them, then it fails more, again, because time is not inherently encoded. But it works really well to detect a lot of things. And I think the reason it works is because not because you can see them directly, maybe, like it even works for detecting like, fungi below ground or frogs. You don't see them on satellite images, but you can see a proxy of things that are precursors of that happening and things that are precursors of that not happening. So those predictions that give you the correlations of occurrence, and then you can see why that is supposed to happen and is not happening. That was the case we did with frogs in Australia. That it was really good. But there's a lot of also other issues because of sampling, bias in the sampling, and I know there's a lot of groups that are working on that. The thing of C-trees, the plot that I usually, it's probably on our documentation, but if not, I'll paste it here in the chat. It's basically the thing that with the documentation of that work is not open, so we cannot share it, but I can share that the regression of the biomass for California on the test set was, if I remember correctly, was 0.997 R square. So it's really good after, I think it was 40 minutes of training on, as I mentioned before. I hope that answers your question. And who others is doing that? Again, I only know the ones who tell me. So I guess the C3s, I know that they are doing that, and also tell me, and they tell me that it's okay to tell other people, which is also the weird part. There's a lot of people who are doing that on the academic side. There is less so on the industry side, but there's a few of them.
Thank you.
Thank you. Any more questions for Bruno?
Yeah, Chimo has his hand still raised, Chimo?
He has asked, I think.
Sorry about
okay.
that.
David from Daniel from Development Seat. Anything you want to say as one of the parents of Clay?
Yeah, sure. Not necessarily as parent of Clay here. I think it's more some thoughts I have as to the discussion we just had on embeddings. I think the model might, in my opinion, like one take here is that the model matters less than you might think, or that a lot of discussion is around. Because presumably these models are big enough and good enough to encode a lot of information that people really want. And so then the embeddings that you're actually using are more defined. Assume you have 3 very good models. Then the differences between the embeddings might be mainly driven by the input data used to generate whatever embedding data set you have. So that also applies for the Google one, where they made a choice to put 1 year worth of data into every embedding layer they have, right? It's yearly. In some of the runs we've made, we had a lot of discussions on what's the chip size to use. So how much, not necessarily the number of pixels, but what's the geographic area we want to cover, right? A good example here is if you want to detect locations of a lake, but your chips are so small that they never show the entire lake together, then it's going to be really hard to do sim search and find that feature, because the feature isn't represented in the embeddings, just not because the model couldn't represent it, but more because the input you gave it doesn't really contain that semantic, right? Even a human couldn't really tell if that piece of water is over a lake or from a river or in the sea, kind of, right? And so I think like then the discussion becomes a lot more about what you can do with these embeddings, should focus also a lot more on what was used and what kind of choices we make to generate them. And then kind of that will imply a lot of what you can do and what type of applications you can expect to run with that applies for prefabricated embeddings, right? But also like it's something important to consider when you want to create your own embedding data set for an area of interest or whatever. And so I think that's something that not to be underestimated. In my opinion, even if I'm a fan of the model we've built, and I think it's it's a bit my baby too, together with the whole team. I do think eventually the models, there will be more and more good models. And maybe in some cases, many of them will be a good solver for a problem. And then the thoughts go more into like, what's the data sets you use to embed in the first place? What are the choices you make?
To complement your saying, Daniel, and then going back to you, to Jonas, I fully agree with you, Daniel. I think the models soon won't matter. I believe for several reasons that all good models will converge a lot, because they are encoding the same thing, Earth. And I think Earth data is much more pure or clear than text data. So models should converge sooner than text to a model that encodes reality similarly. And because they're also encoded they are also rooted in pixel values, they should maybe even the embeddings align across domains easily, even in text, they are seeing this thing happening. There's a recent paper that talks about that. Another thing that you mentioned that I really want to double click is the attention. So all these model transformers, they pay attention to the chip size, but not beyond that through the chips. There are ways to do that through giving them the location, but it is worth mentioning what you mentioned, that if your chip does not include the whole semantic, you might very well lose the semantic. Like if your chip is smaller than a circular plot, you will not see that it's a circular plot, right? And the Google embeddings, they go around that by doubling the size of the chip and only using the center part when they encode that. But that also means that if there is a semantic that is very powerful on the corner of the chip, it will be encoded on those pixels, even though they might not be that. Anyway, one of the things I wish for is figuring out how we can make attention Earth scale. That would be amazing. I don't know how to do that, but that would be great. But anyway, yeah, just to complement what you were saying, Daniel.
Yeah, maybe one more comment also on the cosine similarity discussion. So I also think like sim search or similarity will only work if you actually really want exactly the same thing many times. So if you want the exact same feature, but there's for sure also cases where you want to see different things, right? So maybe you want to see sport fields and swimming pools. That's what you want to do because they're also both sports related. But a swimming pool isn't probably anywhere near a sports field in the embedding space. And so if the kind of things you want to look for aren't very similar to each other in the semantic space, then you need to go to something like could be very small models like random forests or like the more classic ones, support vector machines, etc. They should probably then work really well to be able to say, okay, like here's a group of embeddings that look like swimming pools, and here's a group that look more like sport fields. And so this classifier should then be very reliable in picking up both, right? Even though they're not very similar, it's just two subgroups in the space. So as soon as you're looking sim search, like the click, find by click, find by example type of things work really well in demos, and in some applications they're very useful. But as soon as you have slightly more complex kind of features you want to look for, or a more varying set, then that cannot work by design, right? Like they're not close. These subgroups aren't close to each other in the semantic space. So just that also as a side comment.
This could go on forever, but I see a comment from Jason. I think vector math is not going to work well because of the collocated polysemy. And the fact that negative semantics do not mean opposing meanings. Like staying away from man might not be equal woman. Like I struggle a lot to figure out this, but I think noise is not encoded as a semantic. It's encoded as like a pepper scatter all around embedding the space. There's no reason. I don't see a reason why noise would be. Anyway, I love vector math, but it breaks my brain to figure out how that works.
Thank you very much. Such a nice discussion that we have sparked here. This is exactly why we started this community, to discuss such topics and exchange ideas.
Thank you. Thank you for making it.
Of course. Okay, if no one has anything to ask.
There's a hand from me, Tran.
Okay, then go ahead, please. Mitran?
Hi. Yeah, I have one more question. So I'm currently into causal inference, and there's a technique called like matching. So basically, if you want to study an effect of a policy on a forest that has like a treatment forest versus a control forest that did not have the effect of that policy, you have to do matching between the treatment and control groups so that we don't have any confounders, and basically the variables are balanced between the treatment and control group. So like in the original method, you have to do the matching for the variables that you think are related between these forests. But I'm just wondering, now we have these embeddings, so we don't really need to define the variables that we are matching on between the treatment and control groups. So basically, I'm thinking of like developing kind of a method to use embeddings matching. So like based on the advertise, like how do you think about this approach?
This is a great approach. Thank you for saying that. And I think it could unlock a much different way of doing that matching, in the sense that you're right that it would be easier in some sense, but it would be harder in the sense that, remember that these embeddings don't encode semantics. The embeddings encode chips. So you have the whole bag, like I was saying with the dictionary, you have the whole bag of semantics and associated with a policy, and then the whole bag of semantics associated with no policy, right? So yes, you will include the things you are looking for, like whatever, cutting the trees or not cutting the trees, but it might so happen that the treatment forests also have, I don't know, recent roads, because they rode there to cut the trees, and the control ones, they didn't have road. And because you cannot choose what semantics to include in embedding, you might wrongly associate a confounding factor that is common in both, because you're always working with a bundle of semantics you cannot choose. It's whatever is on the chip is going to be there, and figuring out how to put them apart, either at the model level or at the embedding level, would be huge for cases like you. And to some degree, random forest and other ways, nonlinear ways, do that for you, if, or to the degree that those different semantics are encoded in different sets of dimensions. I don't know if others disagree, but that's my opinion. So thank you for sharing that with me.
I have a follow-up question. Yeah, what do you mean by using random forest so that we can encode different?
Oh, sorry, I meant maybe it's the word. Random forest is a technique where you basically split the data set into different ways randomly, and it's called random forest. It has nothing to do with actual forest. It's a technique to do that.
Yeah, I know about that, but you mentioned that using random forest to encode like the semantic meaning in different embeddings.
When you do random forest, one of the outputs is called feature importance, and that feature importance is to the degree of how much each dimension contributed to the predicting value of that. So in a way, feature importance is the way to distinguish semantics to the degree they can be split across dimensions.
Yeah, for the answer.
Thank you for asking.
Well, at the end, it took more time than I thought. Jonas, I don't know if you have other things to talk about, but thank you for giving me the space.
Yes, of course, we're excited to hear about your expertise, or from you with your expertise. Then someone put something here with a website. We discussed the last session. It might be nice to have as a website for other people to find the community. Someone here suggests to use a GitHub page where we can simply add updates via a pull request. So I'm not sure who put that there.
Oh, sorry, that was me. Yeah, so in the last month's meeting, we discussed, or some people came up with the idea that we need some sort of website. And I thought, I just wanted to propose a way how we do it for our open source projects. And many open source projects do it. They have the source code of the website in a GitHub repository. It ends up on GitHub pages. We obviously can attach a custom domain if you think that's necessary. Otherwise, it would be Earth2Vec.github.io. And every community member is free to change the website. And what we usually do is we have a two-stage process. When you want to change something, you create a pull request, and the pull request can only get merged if someone else of the community approves it, and then you can merge it. So there's no direct commit to main. And that way we have some sort of control, but still all the freedom we like. And if no one has a better idea or objections, I would set this up for us and then introduce you in the next meeting how we can contribute to the website. And maybe I start with a small one, startup website already. So feel free to speak up now if you think it's a good or bad idea, or if you don't care, or whatever.
So anyone have any opinion here to share on that? I really like this idea of having a GitHub page because it's very easy, and especially that everyone can make changes. I hear no objections. So Thank you, Romeo, for bringing that up.
Okay, cool. Thank you.
Okay. Now, before we go to the next point on the agenda, on the feedback round, I actually do have a question for Hamed. I think I saw him earlier in this call. I'm not sure if he's still there. I was wondering about the status of this funding proposal that we submitted a few weeks ago, if you know anything about that.
Yeah, Jonas, was that the proposal Mohammed submitted?
The one that Hamed Ali Mohammed. I see
exactly,
he's still
right.
in this
So-
call. Yeah, exactly.
Yeah, exactly. Is he here? Yeah, exactly. Mohammed, can you give an update on your submission, I think, which was successful to get to the second stage? Okay, I mean, if he doesn't hear us, so I received an email from him saying that so far, I think the first stage was passed. He would submit an additional proposal for the second stage. And there was also the question where, for instance, such an event could be hosted. And that's, I think, why also he reached out to us. So one of the gatherings could be then in IBM Research Zurich. And I think probably also in the US, another event. That's all I know concerning that submission.
Thank you very much. So for those of you that are new to this call, who may not be aware what we've been talking about, we submitted a funding proposal to work on a joint community standard on a file format, essentially, to exchange embeddings, so that we can agree on something that can foster interoperability. Okay, now feedback round. So just in general, if you have any thoughts about this meeting, if you think we can change something or what we can do better, or maybe you have an entire suggestion that we should incorporate into this meeting. So feel free to simply speak up and tell us what we could do differently.
I think there's a couple things I was thinking of.
Yep.
So that was like, as we bring up questions or things that we're wondering about, I think it might be good to capture those as like potential future research areas, or, you know, a lot of these might already be answered in papers that people have already done or written. I also think there could probably be more sharing of papers and new things, like what are the new like events and news that have happened over the past month. I think it's a good place to kind of share updates.
Yeah, I agree with you here. Maybe we could use the I keep saying Mattermost, but the Slack channel more, or maybe have an entire section there where we collect papers.
Romeo, could we also open up a box folder, or you think that would be too much overhead?
Yeah,
for
probably.
access slides?
Yeah, the thing is with Box, it sometimes works, and then sometimes people lose access to the link, and that would be like really tedious.
Yeah.
So let me think. In theory, we can use Git and GitHub pages, but that's a bit tedious because you need to edit files. Now, let's see. Yeah, something like Box, which is working, we need. Why don't we use Google G Drive? We can use the G Drive. And there we have Word documents. We can even collaborate in Word documents to collect stuff. And also we can share whole PDFs and stuff. No? The idea is then basically we can introduce a folder structure and people would adhere to the folder structure. Would that be a good solution?
Is the free license quite limited?
It's 15
storage space,
GB.
right?
15 GB.
Yeah. Yeah. Okay. So then we have just to upload embeddings, so then it works.
Yeah, or someone has a better idea. I'm open to any suggestion. Okay.
Someone suggested sharing updates over the established website.
Yeah, Johannes, can you hear me?
Yeah.
Yes.
Oh, perfect. Yeah, this is Tim Mayer with NASA Surveyor and Earthrise. And I talked to Romeo about this as well, but we have a very similar, well, not a totally similar activity, but we have a GeoAI working group that Biplov and I lead. And the efforts really around building capacity and featuring, relevant talks and sort of tapping into the current state of the art. So I think all the efforts here are fantastic, and maybe there's ways for us to help, provide any of that update that we're also getting in this parallel effort. So if there's updates on events and some other state-of-the-art conversations that are happening in that working group and that audience, I think there could be good ways to bring some of those voices in as well. And I think this website is a great starting place to refine those ideas. That's it for me. And I don't know if you got other thoughts, Biplov.
Thank you very much. So the last point really is, since this is really supposed to be a community thing that we're having here, so we want to switch the moderators so that it's not always from the same organization or from the same project people moderating. So I'm wondering who might be willing to moderate the next call on 12th of September next month.
I can do that.
So thank you very much. Thank you very much, Jason. Then we have our next moderator, and I am thankful that all of you showed up here and participated in this lively discussion here. And I guess see you next month. Goodbye and have a nice day and have a good weekend.
Thanks so much. Bye, everyone.
Thanks.
Thank
Bye,
you.
everybody.
Bye.
Bye.
Thank you. Thank you, Jonas.